We call this Avogadro math because Avogadro's number is a very large number, roughly 10 to the 24th molecules or atoms in a mole of molecules or atoms. And we don't use the number very much, but it helps to know how to multiply and divide by very large numbers, not just for the purpose of finding out how many particles are in a given mass or number of moles, but also just for being able to do scientific mathematics. So, recall what multiplication is. It's like fast addition. Instead of saying something like 6 plus 6 plus 6 plus 6 plus 6, or 6 plus 6 plus 6 plus 6, we say, for instance, 4 sixes, or 6 times 4, which is equal to 24. And you can see here we have actually a 7 by 4 matrix. And if we count the individual blocks, we would end up in this case with 28 blocks. Or if we know how to multiply, we can multiply 7 times 4 and get 28. Now, multiplying by powers of 10 is very easy. Remember that 10 to the nth power is 10 multiplied by 10 n times. Anything to the nth power is that number multiplied by itself n times. So 10 to the 2 power, 10 squared, is 10 times 10, or 100, as you can see here. And 10 to the 4th is 10 times 10 times 10 times 10, or 10,000. That's 1 followed by 4 zeros, 10 to the 4th. Multiplying any number by 10 to the n is easy, just like this. If we're looking for an x that is 52 times 10 to the 10th, then we write x equals 52 times 10 to the 10th. And we could also say 5.2 times 10 to the 11th. To simplify this number and make the first number between 1 and 10, that's scientific notation, we're going to reduce the 52 to 5.2. That is, we've reduced it by a power of 10. That means we have to increase the second number by the same power of 10, 10 to the 1. So 52 times 10 to the 10th is the same as 5.2 times 10 to the 11th. The second number is in scientific notation. Dividing any number by an n power of 10 is also easy. For instance, what is 52 divided by 10 to the 10th? Well, I think we can immediately see that it's 52 times 10 to the negative 10th. We do the same thing we did on the previous slide. We divide the 52 by 10, and we multiply the 10 to the negative 10th by 10, and we get now 5.2 times 10 to the negative 9th, which is the scientific notation. Now you try some. 44 grams per mole, that's the mass of a mole of carbon dioxide, times 1 mole over 10 to the 24th molecules. That will give us approximately the the grams per molecule of this carbon dioxide. Or 3.4 moles times 10 to the 24th molecules per mole of anything. How many molecules are in 3.4 moles? Go ahead and turn the video off and then come back after you've finished your calculations and have written them down. Here are the answers. Number 1 is 4.4 times 10 to the negative 23rd grams per molecule. And the second one is 3.4 times 10 to the 24th molecules in that number of moles.